Hey y'all, today we are talking about the triangle inequality theorem. Okay, before we get into exactly what that theorem says, I want to look at a couple different types of triangles. Okay, so a triangle is created by three sides. Okay, and when we connect these sides, it gives us three angles on the inside. Okay, and we know that all three of those angles equal 180 degrees. Now, the triangle that I have here is an equilateral triangle, which just means all three sides are exactly the same. Okay, now if I start switching out the sides of this triangle, the um, the size of the angles changes as I change the side lengths of the triangle. Okay, now I want to propose a possibility where you have three side lengths that are given and they don't create a triangle. Okay, so there are certain things that have to happen with the three side lengths in order for a triangle to be created. You can see here that the side lengths, they don't touch. The two smaller side lengths are not long enough to meet because this longest side length is greater than these two small ones. Okay, so the way that the triangle inequality theorem states that is that the sum of the lengths of any two sides must be greater than the length of the third side. Okay, so the two smaller sides, that length has to be longer than that third side, is what that's saying. So we can take a look here. If I have this side length with this tiny one, we can actually, it's really close, but you can see here actually when it lines up, it's still not larger than that longest side length. So you would need a longer side to create that. Okay. So, and there's an example of one there. Okay. That will create your triangle. Okay. And this angle, the shorter and shorter they go, that angle becomes more and more obtuse. You can see as it gets closer and closer to the edge there. Okay. So um, I want to take a look at some questions that give you some side lengths, and we have to determine will these create a triangle. Okay, which of the following sets of numbers could represent the three sides of a triangle? So here on uh, this, okay, so here on this problem, they give us three side lengths here, 5, 7, and 12. And based on what we just talked about, the two smaller sides have to be larger than this longest side. So 5 plus 7 is 12, okay? And 12 is not greater than 12, okay? So essentially, that would be two side lengths, or it would be side lengths that line up to be almost or to be exact, okay? And we saw that other one that was really close to exact, but they would be the exact same length here, okay? And it would just make two straight lines essentially if they're exactly the same, okay? So we know that that will not work for the three sides of a triangle. Now, 9, 15, and 25. Well, 9 plus 15 is 24, and 24 is not greater than 25. So that one also will not create a triangle. Okay, 14 and 25 is 39, which is not greater than 40. Okay. Okay, so that does not. Now, 12 and 26 will create 38, which is greater than 37. So yes, this would be my correct answer here. Okay, And you would go through that same process on that problem. You can try that on your own. Now, this last one I want to take a look at says, which of the following sets of numbers could not represent the three sides of a triangle? So make sure that we're reading problems accurately to ensure that we're marking the correct answer. Okay, 9 plus 18 is 27. Okay, and 27 is not greater than 27, so that one will not create a uh, triangle. So I think that's probably our correct answer. I'm going to double check and make sure here. This one is 30, so that one would. This is 22, so that one also would. And this one is 28, so that one also would. So yes, this first one is our correct answer. Okay. Now, um, notice that when you are given three sides of a triangle, okay, let's come back to my picture here. Okay, when you're given three sides of a triangle, you will only ever get that exact same triangle. If I give you three sides of a triangle and one is 8 centimeters, one is 15 centimeters, and the other is uh, 12 centimeters, okay, 8, 12, and 15, I will only ever get a triangle that looks exactly like this. I can rearrange the order of these, okay? I can rearrange the order of this, but look, I have the same exact triangle. Okay, it's just flipped in a different manner there. It's the exact same triangle. All these interior angles are the same. All of these side lengths are the same. So if you are given side lengths of a triangle, you will only ever get that one triangle. Okay. Now, if you are given um, angles, okay, so for instance, they tell you it's a 60, 60, 60 triangle, okay, 60 degrees, and 60 degrees. That means it's 180 degrees in your triangle, okay? I can create a teeny tiny triangle that looks like that has 60 degrees, and 60 degrees. Remember I said the equilateral triangle, all the sides are the same, but also all the angles are the same. I can also create a bigger triangle. Okay. All three angles are exactly the same, 60, 60, and 60. And I can create an even bigger triangle that also has 60, 60, and 60. So what I'm telling you is that when you are given side lengths, it will create one and only one unique triangle. But if you are given angles for a triangle, because every single triangle has 180 degrees and it has to have exactly 180 degrees, you can create triangles with the same three angles that are all different sizes. Okay. These are called similar figures. Okay. They are similar, their angles are all the same. But the side lengths are different. Okay, so we're creating similar figures when that happens. Okay, so this was talk about triangles.